Hello folks, this is 2024 October-November paper 1-1 and the question number is 32. It is concerned with the chapter current electricity. So it says that the diagram shows a circuit with a light dependent resistor LDR. So this is the LDR as it says. The ammeter reads a zero current. So in this arrangement, the ammeter reads a zero current. What is the resistance of the LDR? So from this setup, I have to find the resistance of the LDR. The simple thing given is the circuit and the condition that this ammeter reads zero current. So if I go through the shortcut, what I can say is this thing as a whole is a Wheatstone bridge circuit. And in this circuit, this is the bridge. This thing is the bridge. So this is the bridge. This is a bridge. So when the ammeter reads zero current, that means the bridge is balanced. When the bridge is balanced, what happens is the ratio of this resistance and this resistance, which is 10 by 30, should be equal to the ratio of this and this, which is equal to 6.0 by this is the resistance of the LDR, RL. I've written it as RL. So this gives us RL is equal to 6.0 into 30 by 10. So 10 3 is 30, 3 6 it is 18 kilo ohm. So all are in kilo ohm, so it is simply 18 kilo ohm. And this gives choice number B as the answer. But if I do not consider this Wheatstone bridge circuit because it is not mentioned in the syllabus, so many people argued that this is not a part of the syllabus. So what we can do is we can do it in a different way by means of voltage divider principle. So initially, let me say that this circuit is not available here. This is not available. So what I have is, so the PD across this arrangement is equal to 12 volt. Now the PD across this thing is equal to, let me say this is V2, that's equal to 30 by 30 plus 10 and then into it is 12. So this is 30 by 40 into 12. So 3 by 4 of 12, which is equal to 9 volt. Now if this ammeter has to read zero current, and this PD here is 9 volt here, so it means that if it is have zero current, this also must have 9 volt. So now what I should have now is, if I rub this thing, so I rub this thing here, so let me rub this thing. Now this also is a part of the circuit, now. So if I do so, this thing is equal to 12 volt. This is 12 volt, and this 9 volt is obtained as a part of voltage division. So what I do is, this 9 is equal to RL by, this is RL by RL plus 6 and then into this 12. So I multiply this thing into 9. So 9 RL plus 9 6 are 54 is equal to 12 RL. So 54 is equal to 12 RL minus 9 RL, which gives 3 RL, and from there I obtain this RL is equal to 54 by 3 equal to 18 kilo ohm. So by means of voltage division also it is the same answer. So our answer is definitely 18 kilo ohm, which is choice number B.